use land, you would try, even though it might be very difficult, you would try to produce agricultural products just with workers, yeah? So don't take this too seriously. So try to imagine food produced without land. This is what we're going to get in the next 20 or 30 years. So we will be eating meat that was produced in a laboratory, yeah? That doesn't need any of the tea. Okay, so figures 2 and 3 are just, of course, illustrating this substitution. And I'll come back to this diagram, but this is effectively how it works. You start off with a certain use of labour and land for a given relative wage. When the relative wage increases, you are still trying to produce that quantity Q bar, but of course you move away from labour because it has become relatively more expensive, and you move towards land because it's relatively cheaper. So it's basic substitution, and that's what's reflected in that relation. A high W means a high land to labour ratio. Is this all right, everyone? So cost minimisation should give us that sort of relation. So this is just replicating the previous diagram, figure 2, but now illustrating this on a diagram that has the wage, relative wage, and the relative use of land. And this is just picking those 2 points. So this point here is that point there. So it's saying if the W over R happens to be reasonably low, I'm using a reasonable amount of labour, so the T over L is going to be small. However, if the wage relative to the rental price of land increases substantially from this value to that value, I will try to save on the use of labour, and so I will be using a lot more T over L. Yeah? So that's what you have in here, and I'm going to, for the purposes of illustration, I'm going to use two numerical versions of the Cobb-Douglas. So the crucial thing is going to be that cloth is going to be using more labour than food. And so the share of income that is paid to labour in this sector is going to be higher than in the other sector. So in these in this case, where you have the alpha is equal to half, that line is actually a line with a 45-degree gradient. Yeah? And if, where's the other one? If the food sector is more land intensive, so as you can see now, the coefficient associated with T is 2/3 rather than half, and it makes sense because food should be using a lot more land, more T than L, then the line is going to have half of the slope. Yeah? So all else being the same, a given relative wage is going to be associated with a higher relative use of food. Yeah? So, because the two will have to be the same. Okay, now, in your textbooks, you don't have this line. You actually have something which looks tremendously different, but it's not, because as you can see, our equation 4 that had W over R was equal to 1 minus alpha over alpha times T over L can always be rewritten like this. Is that all right? Yeah? You just flip. If you T over L or L over T to the power minus 1 is obviously the same thing. Yeah? So why is it they use this? I have no idea, but it's exactly the same diagram. So in these lectures, you'll have sometimes a figure, and I'll call it V1, so it's version 1, and then you'll have exactly the same stuff, version 2, and the version 2 is typically the textbook version. Yeah. So there should be no problem at all in travelling from textbook to lecture slides because we are talking exactly about the same thing. However, because Krugman and all the other guys are chickens and believe that you can't use any maths whatsoever, it's all graphical and so on, and sometimes they just move along and think, and ask you to believe something, and here, with just a little bit of maths, you kind of say, yes, this is just a line, and this is how it goes. So for those of you that are at ease with this basic stuff, this is really introductory economics, you're really able to see where the things come from, and you can use even numerical examples. But in terms of the substance, at least this stuff is very well covered in your text.